Continuing our journey through the virtual cloud network at NSXT and how NSXT Data Center fits in, let's take a quick look at the larger architecture of NSXT. What we've got in NSXT Data Center is three functional planes. We have a management plane, we have a control plane, we have a data plane. Right? The management plane, what does that do? Well, that provides exactly as its name implies, the management layer of things. So we have, as we'll see coming up in the next few slides, we have a policy engine that runs in the management plane. We actually have the NSX manager itself that runs in the management plane. vCenter server, my NSX container plugins, right? Things like that. Those are going to run in the management plane. Then I have a control plane. The control plane takes data, takes instructions from the management plane and turns them into something that we can use to program the data plane. Right? The control plane also maintains the runtime state of the NSX network. Right? So if you need to go look at a MAC address table for a logical switch, for example, you can get that information from the control plane because that's where that's going to be centrally stored. The data plane is the part of the puzzle that actually does all of the packet processing and forwarding. This is where my logical switches are realized, or my logical routers are realized, or where my firewall rules actually are brought to bear. Right? This is where everything happens. The data plane is distributed. It's completely distributed across all of my what we call transport nodes. And we'll talk about transport nodes more as we continue on. For the purposes of our discussion at this point, my data plane is made up of my ESXi hosts and my KVM hypervisors and my cloud workloads and maybe even some bare metal servers or my NSX Edge transport nodes. So the data plane is made up of quite a number of pieces, and it's entirely distributed. The management and control planes are contained in a set of three NSX Manager appliances, and we'll kind of go and break those down for you over the next couple of slides here as well. So the management plane and the control plane, like I said, are consolidated. They exist in what we call the NSX management cluster. The NSX management cluster is a cluster of three NSX manager nodes. These are going to be virtual appliances, and they can be deployed either on vSphere platforms or on KVM platforms, depending on what you might have. The management plane provides things like a user interface and an API endpoint. So there's an HTTP server in the management plane that we interact with, right? Either through the web browser user interface or through a RESTful API client. So the management plane is what we tell to make things happen, right? The management plane then instructs the control plane to program the data plane so that whatever we said could happen will happen. Inside each of the manager nodes are three roles. Well, four really, if you get down to it. Four primary roles, right? One is the policy role. The policy role is what we tend to interact with, right? The policy role provides us a declarative state model that we can use to say, this is what I want in my network, so that we can get what we want. The manager role sits in between policy and the control plane to break down that desired state into specific constructs and atomic objects that need to be realized. And then the manager sends that manager role sends that information down to the control plane, the central control plane, which then actually knows how to communicate with the data plane. Now, all of this stuff is persisted or stored in, well, the management plane stuff particularly, right? The policy and the management data is persisted or stored in a distributed database, right? So that's kind of the fourth role that we're showing here. The central control plane is, while certainly some things are persisted, at least during runtime, the control plane is largely ephemeral in nature, meaning that things are going to change and things are going to be more stateless, right? All of the state of NSX is really stored in the policy and management roles. So we have we have these different moving parts inside each of these manager nodes, and each of these roles are clustered across the three manager nodes so that if one manager fails, we're not in any kind of a bad place, right? So that we have our high availability in case of a failure. Now, because my manager nodes are clustered, we probably want some way to access centrally, right? Rather than accessing manager 1 or manager 2 or manager 3, maybe I want to just access my NSX management cluster. Well, how can I do that? One way is through a built-in virtual IP address or VIP functionality. And I can set this VIP for the cluster, this virtual IP for the cluster, and register that virtual IP address with DNS so that that's the IP address returned when I do a DNS lookup on nsx.mycompany.com. We're going to then use that, and we'll point a web browser to nsx.mycompany.com, and it doesn't matter to me which of the three specific manager nodes I'm accessing, just that I'm accessing one of them. Because they're all clustered, they're all distributed in real time, so what happens on one, I can see on three. No problem. There are some caveats with the virtual IP address. The virtual IP address is ultimately implemented using a sub interface on one of the managers. Whichever manager is the one that's been elected the leader. Right? So the leader is going to instantiate on its manager node a virtual Ethernet interface, or a sub interface rather, on the primary Ethernet interface attached to the management network. And then it's going to send out a gratuitous ARP from that Ethernet interface to say, hey, this virtual IP address is mapped to my MAC address. Because we're using a virtual IP address and ARP, right, basically, right, a gratuitous ARP to identify the location of the IP address, all three of my manager nodes have to be located in the same layer 2 domain, in the same subnet. This is just a caveat of how this particular work stream is implemented. So I want to be aware of that. What subnet do these all live in? Do they all live in the same subnet? Great, I can use the virtual IP address. And this provides a great deal of functionality for multi-user access, for automated failover. If my leader virtual appliance fails, a new leader will automatically be elected, and the whole process will be restarted. My VIP will move, and then I can simply continue hitting nsx.mycompany.com to provide that UI and REST API service. But what if my workloads are not all in the same subnet, or not my workloads, more specifically my NSX managers? This is common in the case of a spine leaf network architecture, where the top of rack provides my layer 2, layer 3 boundary, and as such, each of my racks becomes its own layer 2 domain. And for redundancy, I want one manager in one rack, and another manager node in another rack, and a third manager node in a third rack. That's where this really comes into play. If I want to use all of my manager nodes, if I want to use them all from a common IP address, I simply need an external load balancer, whatever that is, right? It could be as simple as an open source load balancer virtual appliance sitting in front of logically in front of the NSX manager cluster. It could be a virtual IP address from a big physical load balancer that's in your infrastructure. Maybe it's a virtual IP address provided by another NSX load balancer, or the NSX advanced load balancer if you're using that platform. It doesn't matter the load balancer, it just needs to be a simple TCP 443 redirect, basically, right? I receive my HTTPS, my TCP 443 requests at the load balancer distributes those to the 3 manager nodes, right? Gives us the same kind of functionality as the VIP, and arguably even a little bit more, since we're distributing the load across multiple NSX managers where the virtual IP address is pinned to a single, right? The NSX cluster VIP is pinned to a single NSX manager. Here we actually can use all 3 of them. Either way works just fine, right? I'm not going to tell you to use one option over the other. We simply have 2 options based on the technical limitations placed in by your particular network architecture and VLAN structure and so on and so forth. Now, NSX policy is what we interact with. This is the top of the interaction chain. When we log into the NSX user interface, that's the policy engine. When we make API calls, that's probably the policy engine. So policy provides us a simple declarative state model to build our software-defined network, which allows me to do multiple things together. When I create a segment, for example, when I create a layer 2 segment, I can configure the gateway interface, and I can configure a DHCP range and so on and so forth, right? All through a single point of reference, right? I want a layer 2 domain with this gateway and this DHCP server and so on, right? It's kind of like walking into a store and saying, hey, I want a cake, right? You don't have to know how to make the cake. You don't know that you need, whatever your cake recipe calls for, a cup of flour and a half a cup of sugar and 2 eggs and what have you. All you have to know is that you want a cake. And that's what policy's good for. Right? That's why we have policies. We want this to be simple. We want you to understand what you're getting without having to know how to implement it. That way we can, at the manager level, right, the layer right below that, we can go and take that request for a cake, and if it needs to be a chocolate cake on premise, we can build out the recipe and ingredient list for the on-premise chocolate cake. If it's in the cloud, we can build the recipe and ingredient list for that lemon cake that's going to go to the cloud. Whatever it is, we have this translation layer underneath that's going to help us figure out what we want. But you, as an administrator, are much more concerned with what you want, not how you're going to get it, right? And that's what policy is there for. Policy is part of the appliance. You're going to get policy when you deploy the NSX manager. This is the first entry point to NSX as far as managing and operating an NSX infrastructure. Like I said, we're going to hand off from policy internally to manager so that manager can break down that desired state request and send that to the appropriate control plane modules to program the appropriate things to do whatever it is we requested. Now, centralized policy management is great. Here again, we have kind of an eye chart slide that you can look at as I'm talking. But what this really says, what this slide really tells us is that central policy was done on purpose, right? First and foremost. So that we can have a central way of describing what it is we're looking for and what it is we want, what the end state is that we want, no matter the platform that underpins NSX, whether it's NSX Cloud or it's a vSphere platform or a KVM platform, whatever it might be. And we don't want to have to worry about the individual platforms. We have a central way of monitoring and providing visibility to those objects. Again, no matter where they are, we're not going to look at a logical switch on KVM any differently than we would look at that same logical switch on ESXi, right? So we're kind of abstracting the actual infrastructure into this ephemeral policy infrastructure underneath us. We want these things, and we can talk to manager and the control plane to figure out if those things are actually actually created and realized and initialized and used, and how well they're being used. NSX Manager takes those things from policy, like I've been saying, and actually builds the recipe, right? It actually says, hey, I need a cup of flour and half a cup of sugar and 2 eggs and a tablespoon of oil, and I need to mix all these ingredients, and I need to bake them in the oven at 350 degrees, or whatever it is, right? Whatever the recipe calls for, right? Maybe you're in a metric country, so you need to know what to set the oven to in degrees Celsius rather than degrees Fahrenheit. So you're using grams and whatnot instead of ounces. Manager knows this, right? And so Manager can make us the exact same cake no matter what my measuring system is. All right. And it's going to do that and push that information down to the central control plane to make sure that things actually get realized, so the cake actually gets baked. So here's the workflow, right? This is what things look like all said and done once we're publishing configuration things. So when I make a change through the user interface, through, that's ultimately going to be through a reverse proxy. We're going to send that data to policy. Policy will persist its desired state in the distributed Corfu database. And then it's going to send that data down to Proton, which is the Manager API service. And Manager is going to persist its state, again, in that Corfu database, so that everybody knows and everybody has stored what that persisted state is, what that desired state is. Now, we could alternately enable the Manager UI and work with Manager directly. We can work directly with Manager APIs to work with Manager directly, to work with Proton directly. Generally speaking, we're not going to do that, however. Generally speaking, everything is going to be managed through the policy engine first, and the policy engine will be the piece of the puzzle that interacts with the Manager piece. So, what do we want to take away from this video? Manager, the Manager appliance, has multiple things going on, right? There's lots of stuff going on in the NSX Manager. Policy is intent-driven. Manager is more imperative. Manager is much more specific and step-by-step, where policy is more of a big picture thing. We want to deal with policy, not with Manager, when and where we can, right? Those are the key things we want to get out of this. Come back and join us for more videos from the NSXT Data Center 3.0 Install, Configure, Manage class. We've got a lot of good stuff coming up. Can't wait to see you there.